Hello everyone, welcome to my channel. This channel is for the purposes of educating, and we generally try to focus on theories of everything, all-encompassing theories that can help you in your life if you learn them, become aware of them. And we usually do look at theories that are pretty obscure so that you probably don't know about them or don't know enough about them. Things that have been kind of blocked out by the powers that be, probably for good reason. Like they might actually help you and they might actually be accurate. And today is the 322nd day that we've done on the reciprocal system of theory from Mr. Dewey Bernard Larson. And Larson came up with the reciprocal system way back in about 1930. He had his first inklings of it and doggedly developed the theory over the course of the next 60 years, wrote quite a few books and a lot of articles, gave a lot of talks, had a few followers, even started a journal called Reciprocity, and eventually died in 1990, leaving behind a small cadre of folks who were interested in propagating his work still, although that hasn't happened to a great extent. As I was telling somebody yesterday, I have been studying the reciprocal system since about 2001 or 2002, and in all my years, I have never met another person that has ever heard of Dewey B. Larson. So it's not like it's out there or anything, but we're trying to put it out there on this channel. As far as I know, I haven't seen any other channels that are focusing on the reciprocal system. Part of that is because it's very difficult. It's not inherently that difficult. It's just that you have to unlearn a lot of information, and that Larson, even though he was a good writer, he wasn't the greatest teacher, and so a lot of the information is out there. It's there for you, but you have to kind of dig it out. You have to really be exposed to a few of his works before you can see the consistency in his method. Otherwise, you kind of just think, oh, he's just pulling this out of his hat. Who knows where he's getting this from? But then you see that he's doing the same thing for atomic physics as he's doing for astronomy. You know, he's using the same procedure, and then you see that he's even using that same kind of set of ideas when dealing with some metaphysical issue. And so you can see that there is some internal consistency there. Okay, now the basic idea behind the reciprocal system is that we live in a universe that is composed entirely of motion. The universe is not made out of matter, it's not made out of energy, but it is made out of motion. And for Larson, motion was the relationship between space and time. That sets up a generalized reciprocal relationship between space and time. You can think of motion as more or less a fraction, with time or space as the numerator and space or time as the denominator. Space or time do not exist in and of themselves. They just exist together in motion. An analogy Larson would use is that motion is like a box. If you have a box, you automatically have an inside and an outside of the box. So they come by threes: motion, space, and time. Space is the inside of the box, time is the outside of the box, or possibly vice versa. And so all forms of kind of scientific phenomena units, so to speak, are different kinds of motion, different manifestations of space and time. Time and space both come in 3 dimensions. That's what Larson calls coordinate space and coordinate time. They also both come in a form that is progressing or flowing in what Larson calls a scalar manner, meaning that it has a magnitude, a motion that has a magnitude but doesn't have any specific direction. Larson calls that clock time and clock space. Just think of clock time. The clock is always getting later and later and later, but in no specific direction. You're not saying, oh, the clock is getting later north, or something to that effect. It's just getting later. And the analogy that you would use for a clock space is a balloon with dots on it, or as Larson would say, a rubber ball, or perhaps some raisin bread in the oven. And when you turn on the heat, the bread rises, and all of the raisins, or the dots in the balloon, if you blow up the balloon, all of them are moving away from each other, but in no specific direction. That is a scalar motion that Larson calls clock space. They're all getting farther and farther apart. If you sucked in the balloon, they would all be moving closer and closer together. And then space and time also only come in discrete units, meaning there's a minimum unit of space and a minimum unit of time. If you don't have a full unit, you don't have anything. So you have to have a full unit of space before you have any space. And that unit is small, microscopic, but 4.56 times 10 to the minus 8 meters. With time, that unit is even smaller, 1.52 times 10 to the minus 16 seconds. And you have to have that full unit before you have any space or time. And if you have exactly 1 unit of space in 1 unit of time, then you have the speed of light, which Larson refers to as unit speed. 1 over 1 equals 1. And so in Larson's system, the speed of light is unit speed, the background or the origin or the ether or the state of rest, the null point, the 0 point. So in a reciprocal system, the 0 point is actually 1. Whereas in the legacy science system, the 0 point is 0. It's from a stationary point. But in Larson's system, you have a universe made out of motion. So motion is going to precede everything else. And so the state of rest in a universe of motion is motion outward at the speed of light. That is the 0 point. That's the reference point. You make your measurements from that. Is it greater or less than the speed of light? And that really sets up the idea that half of the universe is moving faster than the speed of light. Larson calls that the cosmic sector. That is the sector that is completely unfamiliar to legacy scientists who believe in Einstein, who tells them that the speed of light is the maximum speed of the universe. In Larson's system, the speed of light is the midpoint, or the 0 point of the universe. And then the slower than the speed of light half, Larson calls that the material sector. That's the half of the universe that the legacy scientists are comfortable with. Now, because of the reciprocal system postulate, what you have in the material sector is identical as far as general, not in absolute, specifics, but generally, what you have in the material sector is identical to what you have in the cosmic sector, except that they are inverted or reciprocals, meaning that if you reverse the roles of space and time, then you get the picture of the cosmic sector. So in the material sector, you have coordinate space, 3 dimensions of space, and clock time. The clock is always getting later and later and later. But in the cosmic sector, you have coordinate time, 3 dimensions of time, and you have clock space. The clock is always getting farther and farther and farther apart. And when you think about the clock space, it's really that space is, expanding at the speed of light in all directions. It's not any particles moving in that direction. Like, so, for example, in Larson's system, the photon, which we measure from, the legacy science standpoint as always moving at the speed of light, from the Michelson-Morley experiment, and, the speed of light is constant. The photon is always moving at the speed of light. That, in Larson's system, that is because the photon is the only particle that is actually not moving. It's not moving compared to what Larson calls the progression of the natural reference system. The space itself is moving, and the photon just moves with it. And so it appears as if it's moving outward at the speed of light. Now, Larson gets into this here in this article that we're looking at today. We started this article yesterday, and hopefully we'll finish it today. But the article was written way back in 1966 by Larson, and it is called The Physical Nature of Space. And so he was talking about, how space itself is progressing, and that the photon is just along for the ride, and things like that. So if you want to get to the start of this paper, you want to go back and watch yesterday's video as well as today's. But we will start here. I'm just going to read like the last sentence of the last paragraph that we dealt with, and then move on to the next stuff. Many of the most important of the new conclusions reached in the development of the reciprocal system have originated from the discovery that certain phenomena hitherto regarded as involving ordinary vectorial motion are actually manifestations of scalar motion of the progression type. So again, he's making this distinction between vectorial motion and scalar motion, and noting that the legacy scientists are aware of scalar motion, aware of the properties of scalar motion, but they have never recognized its significance. They use the example of the expanding balloon from time to time, but they don't recognize that this is in a different motion in kind than your vectorial motion, and it needs to be in kind of a different category. It needs to be thought of differently than a vectorial motion. A vector is an arrow. It's always in a specific direction, whereas a scalar motion is, no particular direction. All of the dots on the balloon are moving away from each other. The farther away they are, the faster they're moving away from each other. And this was observed by the Hubble telescope that determined that all of the distant galaxies are moving away from each other. So, the scientists know about scalar motion, but they don't understand its difference from vectorial motion and its significance. Larson puts that front and center, that this scalar motion is actually the most fundamental kind of motion, and it's at the very core of his theory. Okay, a related point of major significance to physical theory that is brought out clearly by the balloon analogy is that the datum from which all physical activity extends is not zero, but the speed of the expansion. It is evident that if we are concerned with the magnitude of the independent motion of a particle on the surface of the balloon, it is not the measured speed that is significant, The meaningful quantity is the difference, plus or minus, between the measured speed and the speed of the expansion. Similarly, the significant quantity in the physical universe is the deviation from the speed of the expansion, the speed of light, not the deviation from zero. Eventually, Larson, I think, began to call this displacement. He uses the term deviation and difference here. Eventually, he also uses the term displacement. Here is one place where the new theory leads to some modification of previous mathematical relations. But it should be understood that the essential difference between the new theoretical system and previous scientific thought is conceptual, not mathematical. The requests that are frequently made for a mathematical statement of the new theory are therefore meaningless. To illustrate this point, let us give some further consideration to the outward movement of the distant galaxies, the galactic recession. There are two theories of this recession currently in vogue among astronomers. The Big Bang theory, so-called, which attributes the existing galactic velocities to a gigantic explosion that is presumed to have taken place billions of years ago, and the steady state theory, so-called, which postulates that the galaxies are being pushed apart by new matter that is being created in intergalactic space. To these, I have now added a third. My new theoretical system says that the galaxies are actually stationary in physical space, except for some random motions that are too small to be observed, but that they are being carried outward with reference to fixed geometrical coordinates because physical space itself is an expanding system. So far as the galactic recession is concerned, there is no significant mathematical difference between these explanations, and hence there is no mathematical basis for preferring one of them over another. The real test of the relative power of these different hypotheses is the extent to which they are able to throw additional light on unrelated questions. And for this purpose, it is the interpretation that we put upon the mathematical expressions, our concept of the physical nature of the recession, that is significant. Mathematical reasoning or manipulation of symbols cannot take us beyond the bounds that are set by our concepts of the physical realities that are represented by the mathematical expressions or symbols. And in the case of present-day theories of galactic recession, these boundaries are narrow indeed. But when we turn to the new concept of the recession that is supplied by the reciprocal system, we find that this opens up an influence. No, I'm sorry. This opens up an immense new field for investigation. One very important point which immediately becomes obvious is that on the basis of this concept, both the recession and the inverse of this phenomena may occur coincidentally. This is not possible in a universe that behaves in accordance with current cosmological theories. We obviously cannot have the explosion postulated by the Big Bang theory and the reverse process, an implosion, as it is sometimes called, going on simultaneously. Before the idea of concurrent inward and outward motions could be conceived at all, it was necessary to have a totally new concept of the nature of the recession, such as that which has been provided by the reciprocal system. If, as that system contends, objects with little or no independent motion, such as the distant galaxies, are being carried outward by the progression of space itself, then it is clearly possible for objects which do have substantial independent motions to move in the direction opposite to the progression of space, and thus move steadily inward toward each other. Such objects will then appear to be exerting forces of an attraction upon each other, but because they are actually independent scalar motions rather than forces, they will have some extraordinary characteristics, quite unlike those of the forces of our everyday experience. In particular, they will act instantaneously, without an intervening medium, and in such a manner that they cannot be screened off or modified in any way. All of these are, of course, the observed characteristics of gravitation, and it is apparent that the behavior of aggregates of matter in the observed physical universe agrees exactly with the theoretical behavior of objects that have independent motions in the direction opposite to that of the space progression. So he's really saying gravitation is really the opposite force of progression. You have to have the progression first, but then you can have an independent gravitation of the bodies that are being carried outward, and that gravitation can actually cancel out that progression. He was using the term here explosion and implosion. The explosion is the nature of the progression, like the Big Bang, so-called. And then the implosion is the gravitation. That is analogous to sucking in the balloon. Sucking in the balloon, and space is basically moving backward. But it's not really like that, because the space doesn't move that way. Those are independent motions of those dots on the balloon, or the distant galaxies. So I'm not exactly sure, but I don't believe that analogy really holds. Another way to think about it is that the gravity, explosion and implosion, but also that you have gravity, and the progression is actually anti-gravity. So the progression is really a force of anti-gravity, while the opposite of gravity. That's also not completely correct either, because that kind of presumes that gravity precedes the progression, which is not true. So you could really think of gravity more as being anti-progression. Okay. We thus find that by a purely conceptual change, a modification of our ideas as to the fundamental nature of space, without any alteration of previously established mathematical relationships, we are able to extend our explanation of the galactic recession to apply to gravitation as well, thus bringing these two important physical phenomena within the scope of the same general theory. So it is throughout the universe. Each advance of this kind that we make with the aid of the new concept of the nature of space opens the door to further advances in related fields. Identification of gravitation and the galactic recession as two manifestations of the same basic phenomenon leads immediately to complete and consistent answers for many of the most serious problems that now confront the astronomers. Explanations of the origin of the galaxies, the ability of the globular clusters, the stability of the globular clusters, the immense distances between the stars, and so on. Then further development along the same lines enables clarification of relations in areas that the farther afield, such as areas that are farther afield. It says areas that lie farther afield, such as the expansion of solids and liquids, for instance. Thus, a whole theoretical universe gradually emerges as we build item by item on the new conceptual foundation. Okay, that is the end of that article. And again, that was called The Physical Nature of Space. Now, the next one that we're going to read when we start up tomorrow is the counterpart. And you sometimes wonder why you would need the counterpart. If space and time are reciprocals of each other, you would think that whatever you have to say about space, you could also say the same thing about time. And that's true, except for the fact that we live in one part of this universe. And so we see time and space differently because of our vantage point. We live in the material sector. We make our observations in the material sector. And so, we see space up close, but we see time far away. If we lived in the cosmic sector, then we would see time up close and space far away. So, and like as Dr. Bruce Perret, one of Larson's followers, would have said, we only see space. We do not see time. So the difference between time and space is not in and of themselves. It's that we have a different vantage point when viewing the two of them because of the way we are situated in this universe. And so the next article that we're going to look at is called The Nature of Time. So he has to have a different article to explain the nature of time as he does for the nature, or calls the physical nature of space, because these two things manifest to us differently, even though they're fundamentally the same, except that they are reciprocals of one another. So the next article that we're looking at is called The Nature of Time. And I think that this article is a little bit longer than the one that we did today and yesterday, so it might take 3 or 4 days to get through. But look forward to that tomorrow. And thanks for tuning in today. Have a great day.